Hello friends, welcome back to my YouTube channel. I know it's been long since we have not posted any videos in the channel right here. So I am currently working as a senior firmware engineer at Dover, India, and so right now I'm more of focused on delivering contents to all of you, which includes a lot of technical aspects that includes like system design, development, C programming and DSA, data structures and algorithms, and also in terms of driver development, application development, microcontrollers, and some quick bites on different various aspects of microcontrollers, and in terms of communication peripheral interfaces like I2C, SPI, UART, and all of that. So it's overall a mix of all the topics that the embedded engineer uses in the day-to-day activities. So right now we are actually more focused on delivering contents like this. So let's get to today's topic and understand what kind of problem that we are going to solve and how it is going to be of a use for any embedded developer. It can be a fresher or an experienced candidate in terms of code usability and reusability and scalability. Let's get into the demonstration video as well at the end of this session. So stay tuned for more updates. Let us have got any of you have got a task from your lead engineer or from your manager stating that you have to use STM32 MCU board, okay, STM32 MCU board, and do the blinking function of LEDs, or it can be turning on and turning off, so any kind of functionality. So it's all with respect to LEDs for now. So it's the first session here today with respect to the content. So I would not like to go in depth in terms of embedded systems, but let's start with basics. First thing first. So you have got this task. I definitely know you all of you that you may directly jump into main.c function. So main.c function and give a brief right pin. So this is the function or the API that every developer uses in STM32 to turn on or turn off the LED. Yes, that is true. But when it comes to code reusability or code scalability, so is this worth it? Like is it really worth it? So that is something that we are going to analyze and do some kind of a code session wherein you try to understand how it is going to be of use for the next set of developers that comes into the company, or say how it is going to benefit the company if you are going to change the microcontroller from right now it is STM32, change it from STM32 to say another vendor like Nordic Semiconductors or Texas Instruments or any kind of microcontroller. So is the porting easy? That is something that we are going to think of. So when it comes to porting, so definitely there are some kind of changes that needs to be taken care, like say how GPIO right pin. This is something which is specific to the microcontroller STM32. But when it comes to different MCUs, definitely there will be changes in such kind of APIs. So instead of changing at all the code files that you have implemented in your code, it's better to change in one file. So that is something that we are going to do, like a layered kind of architecture, which will help which will help you or the next set of developers who comes into this project, just to change at one place and done, everything is sorted. So we are going to work in that way. Let me delete this off. Now say you have two folders, one is application layer and one more is driver layer. So what exactly is this driver layer and what is application layer? So we are using this function as shown previously. All GPIO right pin is something that we are going to use. So this is the function given by the STM32 vendor. So what does it say? Set or clear the selected data port bit. So we are going to write a small wrapper kind of a function which states that it is a driver which is used to drive the LED on or off. Okay. So this particular file has those set of functions. It can be turning on the LED, turning off the LED, or it can be trying to read if the exact port and the pin is already on or off. So we are going to use it for such kind of functionalities to work on such kind of functionalities. But what about this? You might ask me that question. What about the application? So you have already mentioned you can turn on the LED from here, off the LED from here. So what do you mean by GPIO app.c? Do you have any specific reason why did you create those two files here? Yes, I do have a reason for it. Because say right now you are given a task to turn on or turn off the LED, correct? But when do you do it? So say there should be some kind of a trigger that happens, right? So the trigger can be a button is pressed, it can be like a short press, or it can be like a long press. There are different aspects that we need to consider in terms of the requirement. Say for example, right now in your case, your lead has mentioned to detect, to turn on the LED for every counts, like it can be for 3 seconds, 5 seconds, 9 seconds, 11 seconds. So we are going to frame such kind of a fake requirement kind of thing to work on it. So, but it can be replaced with something else that you'll get to know when we enter the code session. So let's quickly write the driver now. So what are the different things that we'll need in terms of a driver? It can be, it can be setting the LED state. That is one thing. It is set or clear. And the second function that we might require is to understand if that particular pin in that port is already set or not. So let's quickly write two functions, bool rb LED state set. So for now I'll give it as void, and let's all GPIO write pin and try to understand what are the different arguments that this function will need. Okay, it will need this one, that is the port and the pin and the pin state. Now let's create one small structure. So this will have these two as the structure members, okay? OLED underscore T. Now as we need these two information, like it is the structure, the port and the LED pin. So let us pass this particular argument as a pointer. Pin param definition, okay? And what else? That is a third state. So we need one more state, not a state, but it is like what do you want to do with that LED? It is like so you want to set that LED or clear that LED. In brief terms, it is turning on or turning off, okay? So let us, so for the first argument will be port and the second argument will be pin, clear, comma its state. So to declare the state, we need to create a enum quickly, LED states underscore LED on, comma underscore LED off, okay? Now let's get this as a form of argument or a parameter to the function and declare as LED state. LED state. Now let's copy the same as the argument to the function all GPIO write pin, and for now we will return it as true, but definitely in future if you guys want to do some kind of a check to understand if this particular pin is set or not, and depending on that if you give a return, it will be pretty good. So now the next function is bool rb check if LED is active. Okay, I've done a small spell mistake here. Okay, let me make this as an assignment for you guys and comment down in the comment box on how you can write this function in a very optimized way. So for now I'll keep it empty and I'll not use it, but definitely I'll be showing this demonstration in the part 2 of the next video that is going to come up for GPIOs. Yeah, so I think we are good with the driver for GPIO or in terms of LED. So yeah, so we will want to set the state. So LED state is here, pin definition is here. Yeah, whatever pin definition is coming from this particular, based on this particular blueprint of the structure, the same is going to be assigned here, port and pin and LED state. Okay, there is one thing that we actually missed. So we have given LED on as 0, but let me quickly verify if it is the same for the argument that we are going to pass. Okay, so reset is 0 and set is 1. So that means in our case it should be LED off should be in the 0 state, LED on should be in the first state, or else there is a high possibility that if we give on it will become off, and if we give as off and it will become on. So that is something that we need to prevent here. So I think we are ready with the GPIO driver.c. Now let's quickly code an application. So as I mentioned that we are not going to use any buttons for now. So that is something that we'll be going to take up as a next topic for the next video. But instead we'll create one fake requirement. Say right now I'm going to fake a requirement stating that bool rb simulate button presses. Okay. So we are going to pass a counter int, and let's say if the counter value is equal to 3, then turn on the LED 1, or else if UI counter value is equal to 5, then turn on the LED 2. We are going to use 4 LEDs, okay, for this requirement. 1, 3, 5, 7, 9 and 11, or I can say 12. So here we are going to reset the LEDs. So let's get this back into action. So we will need pin. Okay, we have to define which are the different pins that we are using for our requirement. So we'll quickly define enum LED names, app names, LED names, not app names, underscore LED 1, comma underscore LED 2, LED 3, for LED underscore 4, and as this is a type def, we'll quickly make it LED names underscore t. Okay, now we need to define which are the pins used for these individual LEDs, like what is the port and what is the pin we are going to use. So what we'll do is we will quickly go to driver.h, as we have defined a structure here. We'll quickly define an array of structures. Okay. OLED pin definitions of, say, max LEDs. So which is equal to, now we are going to define the port and pins for each LED that are defined here. So we will do it as GPIO E, comma, I have noted down the LED pin numbers for our requirement that we are going to fetch. Okay. Nine, 10 and 11. Clear? Okay, so we are good with the LED definitions as of now, and let's quickly see what are the other things that we need to take care. So the next thing that we need to perform is initialize these GPIO pins. So if it is a push pull or a no pull, or what kind of configuration you are using, is there any alternate function that we are going to use? So these are some of the information that you will get from the data sheet. So I request you to thoroughly go through it. Today we are more of focusing on writing the application part and not the driver part. So right now I can just say we need to initialize the function, and more of that information will be available through the data sheet. So let's quickly initialize it. LED app init. So RV return of type void. Okay, void So let me quickly get that function status here. I've already made it ready by referring to the datasheet. So for E port, we need to enable this clock and assign the appropriate LED numbers by doing a OR operation. So once that is done, yeah, we need to change the name here. Okay, so once that is done, we are going to initialize the GPIO E port with the parameters in this way. So alternate function is 0, mode is output push pull, pin is, these are the different pins that we are using, that is 8, 9, 10 and 11. So pull is GPIO no pull, speed is GPIO speed frequency low for now. So I have a quick question for you guys. Comment down the value of UL pin definition in the comment section below. So I would like to know if you guys really understood it by referring to the datasheet or not, and tell me what the value of this particular variable might be. So that is the second task for the day. Okay, so right now we are ready with the structure, I mean the layered functions in different layers like driver and application. Now let's quickly define the LEDs. So here we are going to set the LED state. So we need to do it as on. Okay, let's see if this matches our requirement. Two parameters are defined for this particular function. We are going to pass the LED definition of each LED that we are going to turn it on or turn it off. So we have done that. Yes, very true. Now let's make it for other LEDs, like say GPIO LED 2, GPIO LED 2, then GPIO LED 3, and GPIO LED 4. Okay, good. Now let's turn it off. Let's turn off all the LEDs when it comes to the counter is like when the counter is reaching the value 12. Okay, 3 and 4, and let us bool be written code is equal to false, and let us make this true for the user to understand that you need to clear the value of the counter to 0. Let us declare these functions. We are good enough till now. Let's initialize this function in main.c. and let us write a small piece of code to simulate the button presses by passing the counter value in main.c inside the while loop. So we have given a delay of 1 second. Let me use this LED counter. So when the LED counter is 0 or 1 or 2 or 3, when it comes to 3 it will set LED on. When the LED counter is 5, it will set LED 2 as on. When it is 7, it sets LED 3 as on. When it is 9, it sets LED 12 as off, not on. See, these are few of the things that we need to take care as developers. We need to review the logics that we write from top to bottom. So starting from main, is it all good or not? I know definitely we'll get to know through the output behavior, but still it is a good practice to check the function if it is written with a proper logic or not. Okay, so we need to extract one more thing. If the function returns as true, then set this particular state, the value of this particular variable to 0. Okay, I think we are all good from our end. Let's quickly build our code and see if there are any issues that pops up. Okay, so max LED is undefined, so I need to define it here. Okay, done. And the next issue is here. Okay, great. Now let me quickly, oh, okay, incompatible type. So this is of type pointer, so we need to pass the address here. So let me copy this, paste it in all the other places. Great. Now let us build this code again. Great. So many number of, okay, max LED count. I think we are good at least for now. Super. Super. This is something we need to check, but for now I think we can ignore that warning, and we will try to quickly flash the code base to our LED, to our microcontroller, and see the output of this. Great, the code is flashing and it is all good. Let us check if it works fine. Let me see if it is working fine. No, the output is not great. There is some kind of an issue that has come up. Let us see what is that issue right now. LED 1, LED 2, 3 and 4. So you are going to set the port and the pin state. Oops. Okay, it is having some issue, I think. Let me reconnect this again. Okay. Let us stop the debug session and replay the code. Let me flash this code again. Till then, we will try to analyze what might have gone wrong, why it is not behaving as expected, and try to understand the root cause for it. Okay. So RBLED set state takes one parameter to this function definition. So it is the port and the pin which is right, and the LED state that we are trying to set, and it returns true. So let us see what is wrong with the application here. So 3, 5, 7 and 8, and we are going to set it and clear it off here. Let's see what other things might have gone wrong. Now let us play this code if it is in main.c quickly. Let us see, wait for the behavior because we have given a counter of 3 seconds, and see if it is doing good or not. I think this might be giving some kind of an issue. So for now, I'll return it as true. Sorry, let this be there, but definitely let me do some kind of other logic and see what might be going wrong if I'm returning it as true. But right now it is returning false, I'm pretty sure on that. Okay, so it should work now. Let me comment this out and see if it is working normally. Okay. And this is all, this code is good, but let me verify what is missing. Driver.h, we are doing it off, that is 0 is equal to 0. There is something wrong with the code that we have written. So let us analyze what is wrong. Main.c is closed. Okay, there is some kind of an issue. App in it. Okay, this is not declared. This is implicit declaration. I'll quickly add it to GPIO app.h and okay, let this be here. Should be fine. Oh, simulate button presses. Oh, yeah. The problem is here. So we are not passing the LED counter, right? So this is something that needs to be passed. And now I think it should work because we are not passing the LED, the counter that we are trying to simulate the button press. So it is not going inside any of the cases. So hence the LED is not turning on. So this is one of the reason why the implicit declaration warning needs to be taken care of. So we'll get to know what exactly the problem is. So let me see if it is turning on now. Yeah, this turns on right now. So I hope you guys are able to see it. So the LEDs are working. Yeah, now it will not glow again because of one reason. So we have made this as true. We have commented this out. So it should be on. It should be enabled. If it is true, then we are going to reset that particular counter value that we are passing as an argument to this function in main.c. So it will reset and again it will restart from 0. So when you get 3, the LED 1 will turn on, LED 2 will turn on, when it is 5, when it is 7, LED 3 will turn on, and when it is 9, LED 4 will turn on. So it somehow works like this. So you can see 4 LEDs now. It will go off, again it will turn on one by one for every count of 3, this count of 5, then count of 7, and count of 9. Yeah, I think this is working perfect as expected. So the controller name is STM32 F303 for your reference. I'm going to drop all of the details in the description down this video. So please do have a look at it. Definitely I'm going to upload this code in my repo in the Git. So if you want to explore more on this code or do some kind of modification, please feel free to get this done from your side. And also do let me know, as it's a big learning process for everybody, including you, including me. So I definitely would love to explore more of the different approach that you have instead of doing in this way. So and understand what might be the major difference in that particular approach and compare it with the approach that I have implemented here. So please do let me know if you guys have a different approach in the comment section. It's all open for you guys. And thank you so much for being patient and listening to me, and definitely hit the subscribe button down below in my channel so that you guys can be updated with all the different videos that are going to pop up in your phone notification in the coming weeks, because a lot of contents that are being cooked up in this way. So I hope you guys enjoyed the session, and again I really appreciate the time that you guys have spent here. Thank you so much for being here and listening to me throughout the session very patiently. Thank you so much again. Have a good day. Bye.